guys, welcome to Tech with Presidents. In this channel, I explain artificial intelligence and machine learning buzzwords through storytelling. Today we're going to be talking about two very popular terms in machine learning, that's overfitting and underfitting. Before we go into that, do you notice my pretty glasses making me look like a nerd? I'm not, but yes, get ready to be sick of me and these glasses. Anyway, let's get down to the business of today. Call me best friend. When we are building a machine learning model, our focus is on training the model to be able to recognize patterns, correlations, relationships within the data set, the training data, so that when it is giving new data that it has not seen, it will also work well. So basically, we're looking for a well-fit model. Unfortunately, sometimes the model either becomes overfitted or underfitted. So today, those two problems are what we're going to be discussing. So first of all, let's start with underfitting. So what is underfitting? Underfitting is basically when a model is too simple. So the model does not learn enough patterns in the data set, so it performs badly on both the data set you use to train it and the data set you use to test it. It performs badly. It doesn't capture the complexity of the data set. So basically, in technical terms, we say the model has high bias. So that means the model already have this preconceived notion of what it expects the data set to be. It expects the data set to be simple, but then the data set is actually complex and it's not able to match up with the complexity of the data set. Let's say we're working with a house prediction model. So basically, the model is supposed to be able to predict the prices of houses, and the model is only looking at the number of rooms in the houses. Obviously, you also have to consider market trends about you also have to consider the location of the house, the size of the house. There's so many other factors, but the model only focuses on one, which is the number of rooms. Like, how will one number of rooms tell you the price of a house? So the model is too simple that it doesn't really find relationships within the features. So overfitting is the opposite of underfitting, and it's basically when a model is too complex. The model is so complex that it memorizes its training data, it memorizes noise, information that is not required, it basically just crams it like it's going for an exam. On training data, it performs well, but on a test data, on a new data that it has not seen, it performs poorly. So basically, it's like you have an exam and you go and cram last year question that your teacher said. But this year, the teacher decided that, okay, I'm not going to set that, I'm not going to repeat that question, I'm going to set a new one. Obviously, you will fail because you did not try to understand the course, you did not try to actually understand the subject or whatever a teacher taught you, you just went to cram questions. So now that you have a new set of questions, you do not know how to navigate it. So that's basically how an overfitted model works. In technical terms, we say the model has high variance. So that means the model is sensitive to any small fluctuation. It packs everything as pattern. It doesn't filter. It doesn't say, okay, this one is not necessary, this one is necessary. It just gathers everything together. And an example is like a spam filter that blocks every message that has the word discount in it, because when it was trained with messages that included the word discount. So it has memorized it as, okay, any email that contains discount, it means that the email is spam. But some legitimate emails contain discounts. Please, my fashion brands, they give me discount and they're legitimate. So that's just it. That's how overfitted. So overfitted is too complex and underfitting is too simple. So how do we fix this issue? We don't want a model that is too simple. We don't want a model that is too complex. We want a sweet spot. We want it to be a perfect balance. We want a well-fitted model. So I'm going to talk about solutions to both of them separately, not together. So I'm going to talk about the solutions for underfitting and the solutions for overfitting. So there are so many ways to solve the problem of overfitting and underfitting machine learning, but for the sake of the length of this video, I'm going to talk about two for each of them. So let's start with underfitting. So we know the problem with underfitting is that it's too simple. So a way to fix it is to use a more complex model, because a more complex model will be able to better grasp the complexity of the data set that it is learning from. Number two would be to increase the data. So let's say you're working with a very simple data set. Adding more data, adding more features can help the model to be able to find more meaningful patterns within the data set. Now let's look at overfitting. To solve overfitting, the first one, we already know overfitting is a problem of too complex. So you have to do the opposite. You have to try to use simpler models. Number two is use regularization techniques like L1 regularization, which is lasso regularization, and then L2 regularization, which is ridge regularization. So these techniques, they penalize the model, they penalize complex models so they don't overfit. So basically they are warning the model, they are telling it, I'm warning you, don't ruin this thing we're doing. Oh. So just to sneak in a third one, feature selection can also help with overfitting. Feature selection can be a way for the model to focus on what is important. So when you trim down features that are not important, you tell it, this is what I want you to learn from, this is what I want you to focus on, and then the model will be able to learn patterns that are actually useful. So here is a quick recap of everything we've discussed today. That's all I have for you today. If you found this video helpful, please like, share, and subscribe. Your support means the world to me. If you have any questions to ask, please drop them in the comment section. I'll definitely give you a response. I'll see you next week where I discuss another artificial intelligence and machine learning buzzword or jargon. So be there, best friend. Thank you for stopping by and for staying with me to the end. Bye.